Hail my fellow enthusiasts of the arcane and welcome to Advait's Quant Lab. Today we're going to be looking at the question and show that any covariance matrix is symmetric, positive, semi-definite. First, let's tackle the idea of the covariance matrix being symmetric, and this comes quite naturally. If we say we have random variables xi to xn, and these are the random variables in which we're going to try and find a covariance matrix for, and we'll denote the covariance matrix as sigma x. Then we can write sigma x of jk as the covariance of xj, xk. And we know that the order of the covariance doesn't matter. So we can rewrite this as a covariance of xk, xj. And this is in fact the covariance matrix of kj. And what this is showing is that for any indices, so we have our covariance matrix, say sigma x, and we have our variances of each random variable across the diagonal, that any value on the top, the indices just get switched around. So what that means is that it gets reflected across this diagonal, meaning that the matrix is in fact symmetric. So that is sorted now. Now what we've got to do is we've got to go to the idea of the covariance matrix being positive semi-definite, and this is where it gets slightly interesting. If we first recall the definition of a positive semi-definite matrix A, for example, so matrix A is positive semi-definite if there exists a vector which is not equal to 0, such that that vector transposed times by the matrix times by the vector is greater or equal to 0. Now, if we look at this definition, we can maybe initially spot that, okay, greater or equal to 0, we know that the variance is also greater or equal to 0. So we can say that, okay, the variance of, let's say, some real constant ci, and let's summate it. Summation from I equals 1 to k of ci xi. This is the double summation from I equals 1 to from I equals 1 to j equals 1 to n, being a square matrix, of ci cj times by the covariance of xi xj. And this can be written in matrix form as C transpose our covariance matrix times by C. And we know that this is greater or equal to 0, so we can write here that it is greater or equal to 0. And if we say that Ci is real, and that all of them are not equal to 0, which satisfies this part of our definition, we can say that, yes, in fact, sigma x, or the covariance matrix, is positive semi-definite.